The ones in standard form, we found our x and our y intercepts. So if we were making our table, we put 0 in for y and 0 in for x and found those 2 points. Again, we're pretending it says 4x plus 3y equals negative 12. And we do our x and y intercepts because they're kind of easy to do. If I put 0 in for y, it gets rid of the y term, so I'm just taking negative 12 divided by my coefficient of x, negative 12 divided by 4, negative 3. That's pretty easy to do. If I put 0 in for x, I get rid of my x term. Negative 12 divided by the coefficient of y of 3 gives me negative 4. So my x-intercept is at negative 3. My y-intercept is at negative 4. I have my 2 dots. I can now draw my line. Again, I double check. Should that line be solid or should it change to a dash line? It's going to have to be a dash line. Now, this is the weird part, because you can't always follow that inequality symbol, because if I would solve that equation for y, sometimes my symbol switches around. So what we do is we test the point 0, 0. 0, 0 is right in the middle and it's easy to test. What I'm going to do is I'm going to put 0 in for x and 0 in for y, and then see if I have a true statement or not. Well, if both of these two things are 0, it makes that whole side 0, right? Is 0 less than a negative 12? Is 0 less than a negative number? It's not, right? 0 is bigger than a negative number. So that means I'm not going to shade the 0, 0 side. I'm not going to shade this side. That means I have to shade this side. So I end up shading below my line over here. So number 8 here, if I am going to find my x and my y intercept, putting 0 in for y and 0 in for x, I have negative x plus 3y. We're pretending it says equals 6. If I put 0 in for y, what would I get for x? Negative 6, exactly. Because I'm going to take 6 divided by negative 1, negative 6. And if I put 0 in for x, I'm going to get 2 for y, because we're taking 6 divided by 3, which is 2. So my x-intercept is negative 6. My y-intercept is positive 2. Again, on these, sometimes you do get fractions, and you have to use the plot point tool and have the computer plot it. Then I draw my line, and I double check. Should my line stay solid, or should I change it to a dashed line? Going to be dashed. So I've got to make it a dash line instead. Now I'm going to check my shading. I'm going to test 0, 0. So negative 0 plus 3 times 0, is that less than 6? Again, this whole side's just going to end up being 0 because I put 0 in for x and for y. Is 0 less than 6? Yes. Yes, it is. So that means we do shade the side where the 0, 0 is. This time we're going to shade over here below our line because the 0, 0 is below our line. And so it looks something sort of like this. Number 9, we have 2x plus 3y. We're pretending it says equals negative 9. We're going to find our x and our y intercept. So if we put 0 in for y, what is x going to be? Negative, right? Yeah. Negative 4.5. or negative 9/2 if you put the fraction in. The computer will take it either way. If I put 0 in for x, I'm going to get negative 3, right? Negative 3. So on the first one, you'll have to use the plot point tool and let the computer put the -4.5, 0 on there. We're going to just estimate where it is because we know about where -4.5 would be. And then the 0, -3 would be my y-intercept so that I can draw my line. And should that line stay solid or should it change to dashed?
Solid.
It's going to be solid, which we have, and then again we're going to test. If we test 0, 0, 2 times 0 plus 3 times 0, is that greater than or equal to -9? Is 0 greater than or equal to a -9?
No. Yeah.
Yes, it is. 0 is greater than a negative number, right? The equal to, it's probably never going to be, otherwise you'd be right through 0, 0. But yes, 0 is greater than -9, so yes, that's a true statement. So we are going to shade the side with 0, 0, which is this side up here. And so my graph looks something sort of like that. The next ones, we are just going to translate these into inequalities.